CPCB centers as well as by satellite imagery through remote sensing equipment like in developed countries. These low-cost monitors can be used for hotspot identification such as industrial sources. That's what was told by the Maharashtra Pollution Control Board member secretary to me regarding their deployment. These sensors can be fixed on moving vehicles with Google Street View and can help in identifying potential pollution sources of interest. In London, they are using those cards for measuring the pollution levels at different points. These low-cost monitors can be coupled with wireless networks or used in combination of mobile applications to aware a person. It means for personal monitoring also about personal exposure monitoring and health risks. In Hong Kong, the hospitals are also connected to the air pollution monitoring stations. So alternative technologies will help people to learn more about their microenvironment, this local environment, to supplement the regulatory systems. It will help to demystify. It means it will make it more popular and help the people to connect with the problem, their day-to-day health problems. They can make aware of it. Public health challenge and risk assessment will require such monitoring approaches to reduce exposures and risks. So in this, the community participation through citizen scientists is essential, and also the NGOs can be involved. Yes, in Bangalore. In Bangalore, the NGO is involved in the monitoring of the air pollution at the local level. And even Green Tribunal also told to involve the students of the schools and colleges in air quality monitoring. Even to my mind, the UGC also can incorporate the projects under environmental studies at the degree level. And we can bring the audio visual media and print media into this aspect so that the authorities can release the air pollution levels on every day, like weather for the TV channels, and they can announce or put it on scrolling. That is how we can make it, make the people aware. With this, I would like to invite Ravindra Garu, who is the chief scientist, UPTRI, and I will give his introduction a little. Ravindra Garu is well known to all our environmentalists. He worked in Pollution Control Board and he prepared the action plan for Hyderabad city. So I request Ravindra Garu to speak now.
Good morning. Good morning to all of you. Thank you very much for giving an opportunity. This topic is affordable technologies, where we have experts also there, Mr. S.K. Gupta ji and Ian, who can throw a light on various technologies. In the meantime, I will just explain the action plan, which is some brief highlights of action plan. Next, I will share the presentation. 1 minute. Yeah. Is it okay?
Yes, good.
Is it visible?
Yes, visible, sir.
Okay, right. Yeah. So in the affordable technologies, I will just highlight some of the points which we have to see. We all of you know very well about the NGT directions, honorable NGT direction. So various directions were given for control of air pollution, river pollution. So many areas the directions were given. In the same way, this air pollution also OA number 681 of 2018, some directions were given. These directions were given to Central Pollution Control Board to coordinate with all the state pollution control boards. Accordingly, the Central Pollution Control Board has directed all the state pollution control boards in the particular regions to constitute a special air quality monitoring committees and to supervise and to prepare an action plan. Accordingly, in our Telangana also, the government has issued a GO. As per the GO, six departments were taken. Of course, in this EPTR is also one of the group. So, EPTRI, Pollution Control Board, and all other transport and other departments to supervise the action plan on air quality, which was similar to NCAP, which is for Delhi. Similar action plan was prepared. The action plan is so exhaustive, but just I want to highlight some of the important points in the presentation. So what is the things to be done in the industry, which actually in my previous webinar we could have missed. Actually in my previous webinar I have more stress on vehicular pollution. As Narendra was asking me all the times, what is the issue of industries? So this time I have included some of the steps which are to be taken by the industries and their issues and challenges. Industries pollution, actually we have to do lot of intensification, and every industry should prepare an action plan as a part of this air action plan, how to control the air pollution from the industries, which is actually going on. There are some polluted industries which are nearby the cities, which should be banned and should be kept in the IDS only. That is another thing. Next is most of the industries, as per our knowledge, around 300 industries are having online continuous emission monitoring connectivity to the Telangana Pollution Control Board and also Central Pollution Control Board and other facilities. So this facility is there, but there is no audit so far. So what happens, whatever the industry the data is being transmitted, which is to be just we are getting the data, whether the online systems are continuously working, whether it is properly calibrated by the supplier and other things, all the things is there. Otherwise the data becomes redundant, which is not suitable for taking decision. So there is a necessity of audit and of course calibration also, calibration of the all online analyzers. Remote calibration is also a recent topic, which is also to be taken up by the respective pollution control board without the knowledge of the industries. Similarly, there is a lot of cleaner production technologies, IITs, various IITs and various pollution control boards are opened the cleaner production cells. So cleaner production is one of the important things. Many industries also release fugitive pollution, especially sponge iron, steel industry, coal mines and other things, that also to be taken up actually, which is a negligent part, that also to be taken up. Similarly, air pollution control equipments, earlier the technologies ESP, now there is a lot of technologies, most advanced technologies like wet ESPs are there, reverse airbag houses, RABH and other things, which is most advanced with 99.5% are so pollution control is possible. So because the ESP also sometimes fails, we have seen in many thermal power stations, still the chimneys are belching smoke and in addition, the action plan for local idea is very important. Each idea we have to identify. Each idea, different ideas will have different pollution. That also. Inventoration of industries, and that's very important. We are lacking. Inventoration of industries there. At the click of the button, we should see what is the industry's pollution, what is the parameters, what is the air pollution, water pollution. Everything should be in there at the click of the button. Next. MSI rules are very important. A lot of accidents we have seen in LG Power, Emerson, so many places. In Hyderabad also we have seen fire accidents, Actually, this manufacture, storage and import of rules are very background. Actually, they have to be implemented. That is floating roofs or fixed roofs in especially the petrol and refinery, where there is a possibility of leakage of volatile organic carbons, what we have seen in Maharashtra BPCL refinery and various other places. Public outcry is there based on this leakages from floating and other roofs structures. LIDAR, leak detection and ranging, is very, very important. If volatile organic carbons are highly more in Hyderabad because of pharma industries, where we require study of volatile organics, and control is very, very important. The VOC control based on the LIDAR study, leak detection and range studies is very, very important. Gases control also very, very important. Not only sulfur dioxide and nitrous oxide, various gases like ammonia gases, HC, H2SO4, HCl, like acid mist and other things are more common prominent in our Hyderabad. So that is also to be controlled with the suitable scrubbers, and whether the scrubbers are properly running or not, that is important issue. That is a challenge actually. SEMS necessity, this continuous emission monitoring, all the industries are generally connecting with continuous emission monitoring. So as I already told, there is a necessity of online calibration and its proper connectivity. Mobile monitoring vehicle also, as Naran Rao telling, in Maharashtra we have started. So mobile monitoring is also very, very. Clean fuel is very important. Actually, we have CNG, LPG, PNG, pressurized natural gas from Bhagyanagar Gas Limited. Even from petcoke and coal, because petcoke and coal is going slowly being banned from the coal gasification, coal bed methane or coal conversion into gasification is one of the best technology which should be promoted in future. Thermal power stations, most problem is sulphur reduction. There is a very drastic standards were given. Of course, there is a relaxation up to 2025, but this sulphur is more pollutant, up to 1200 milligrams or per cubic meter or more it is there. So flue gas desulfurization is very, very important, but there is still a lot of delay in our India. That is should be. Brick kilns also, natural brick kilns are there, but there are a lot of natural new technologies came. The new technologies should be adopted by all the existing brick kilns, so that emissions will be very, very less. Thermal power stations also, nitrous oxides and nitrogen dioxide measurement is there as of now, but the control technology is still very slow, lacking selective catalyst reduction or selective SCR, SCNR like this to be implemented to reduce the nitrous oxide. Coke oven plants are highly polluting, especially in Visakhapatnam Steel and other like iron plants and other things. There is a lot of pollution, whether it may be phenol or so many pollutants which is to be controlled. Coal mines we know very well. We are very rich in coal mines in Telangana. So a lot of steps to be taken in controlling the dust levels and emissions, everything in coal mines. Exhaustive environmental monitoring is required. Similarly, iron and steel, this is some example. Generators also sets also produce lot of NOx and other things which are to be. Waste heat incinerators are very, very important, whether it is biomedical waste incinerators or hazardous waste incinerator or compost incinerators also. There is a possibility of dioxin, furans and other compounds. So their design and proper operation is very, very important. Comes to the vehicle air pollution, we have already discussed. Some of the new techniques and new issues are PUC program is already there for the long back, but it is not that much effective. Everybody knows it should be online and connected to the RTA server. That is one of the important, which is I think seems to be coming shortly in Telangana, and also this making mandatory. That is whatever we have taken PUC, the record should be available with RTA and they can check it. Not only that, this colors stickering, actually color stickering. Stickering is means every month we have to have some sticker. Red color for January, green color for February. Like this, every 6 months we can change it. So what happens once we see the color, whether it is circular sticker or a square sticker, so that what happens from long distance only the traffic police can see whether this is having the suitable PUC or not. That should be very important. Freight transport is very, very important. All the lorries and other things should operate in the night time only, so that the daytime traffic will be very less. Clean fuel and is very important, like LPG, CNG, electrical vehicles also coming shortly. Adulteration of fuel is very, very important, which should be controlled. Multi-level parking is very important. Parking issue is very high in Hyderabad also we have seen. So like other foreign countries, we require multi-level parking. In small area, we require more levels for parking purpose. Public transport strengthening is already there. Electrical vehicles, whether it's MMTS, metro, GPS buses, still slowly coming. Volvo buses, electrical buses are coming, which is important. We do not have any emission certification centers. If we want anything I&M facility for vehicles and other things, we have to go to ARA Pune. Recently we have seen in the newspaper that Automatic Research Institute Pune is establishing its center in Hyderabad, which will be, I think, very useful for especially vehicle suppliers or manufacturers and others. Phasing out of old vehicles, still we have to take a suitable decision. But anyhow, with the government, central government latest policies may be helpful to remove the old, to disband the old vehicles and procure new one. Let us see that. Road dust is also one of the main important. Part-free roads we require, black topping is required. Plastic and bitumen use is the latest one, where the roads will be more time, it will be useful. Uh, reliable also. Mechanical scavenging is there already, but lot of scavenging required. Still manual scavenging is there. End-to-end pavement roads are very important so that there will not be accumulation of the dust. Installation of Vayu at intersection, that is to produce air pollution, like Delhi and other things it is required. Hyderabad we may not require. So it will produce fresh air and remove the all, suck the waste gases and other things. Fresh air is produced in the intersections so that traffic constable and other things will benefit. Green cover is also very important in the medians. Waste burning is very common in spite of many GOs, many awareness. Biomass burning is there. Stubble burning in Punjab and other places is the cause of Delhi air pollution, we know very well. Horticulture waste is also simply we are burning. Dry leaves are burning without the knowledge. People doesn't have any much knowledge of what is the consequence of pollution. When you burn anything, lot of particulates PM10 and PM2.5 will come. That is the issue. PNG is required for cremation also. Actually, electrical crematoria is there, but for gas you can also use it for cremation instead of coal and other things. So that lot of particles will come down. Firecrackers should be banned, just like already there is a ban. Use of LPG also required for and modified chulhas also. Yeah, still some other things are public outreach programs are very important. Public grievance redressal important. Capacity building very important, because whether it is pollution control board or all the stakeholder departments also sufficient manpower who are trained and well aware of the this latest technologies and NGT directions in action plan should be aware, and not only that they have to disseminate to the public. Source apportionment study, it was taken in the Hyderabad around 2006, which also to be updated actually. What is the latest status we don't know. 2006 and 2020, 15 years back the study was taken up. Now with a lot of pollutants are changes and everything is changes, so very good. Emission tracking is also as per CPCB online we have. Apps also there, lot of air pollution apps are there, whether it is Suffer or whether Samir of CPCB, which are very useful to get day-to-day air pollution, all over the India. Some of the action plans is there already, setting up of vigilance, industries to continue real-time emission monitoring, rolling task force and coordinator with other staff departments. And vehicle department traffic also have done lot of things in Hyderabad. So many signal junctions, vehicle actuated technology. This is not fixed time signaling. Signal automatically will open whenever wherever the vehicles are more, automatically the based on the vehicle count signal will be synchronized. This automatically ATC and cameras, all these various VM signboards that will tell 30 seconds or 20 seconds or when the signal will be opened or something. So these are very important, which I think very useful in the future. Yeah, is when command control center is fully operational in Hyderabad, everything can be synchronized. So other we have already discussed multimodal transport, public transport, CNG. So many flyovers are already being constructed under strategic redevelopment program, which will help in free movement of the traffic in our Hyderabad. So apportionment study I already discussed it. It was long back. Some CNG is also available in our Hyderabad by Bhagyanagar Gas Limited. 51,000 is something is there now. It is more than 1 lakh. It is being planned. Presently, lot of CNG is available for use in for industries and others. These are the some of the status. Population is now increased more than 1 crore, but length is around 9,000. So vehicular population is very 48 lakhs. Now it was reached up to 50-60 lakhs also. So we have already monitoring network. Hyderabad, lot of air pollution monitoring stations are there. Lot of state ambient air quality monitoring stations are there. Continuous onlines also there. I think Dr. S.K. Gupta will tell what is the issues and challenges with ambient air quality monitoring stations which are being installed by him, and what is the issues, what is the necessity of calibration and other things also. Actually, there is a necessity of sensors. Even on EPTRI also we kept it small sensor also through IIT, IIIT. They have given one pollution notes, which also Mr. Ian may throw light on that. So the sensors are also there, but regulatory authorities are not given permission. But sensors will give data information. As a part of this use of sensor and utilization, even Bureau of Indian Standards are working on it, and I am also in that member. So that sensors, what is the use of sensors, are going to be discussed in the air quality section of Bureau of Indian Standards. So once the methodology is finalized, so the affordable technologies, that is so low cost sensors, can be procured by anyone and can be utilized. I think this will be all. So these are the some of the stations most of you know. So pollution levels are just graphical. 6 major pollutants only. SO2, luckily we don't have much of SO2. Nitrous oxides are still high, which is causing asthma. CO is luckily we don't have because of BS4 and BS6 vehicles. Carbon monoxide is mostly reducing, but ammonia is still there, maybe due to plantation also. Ozone is one of the highest pollutant, which is gradually increasing. So we have to have control on ozone because of volatile carbon. BTX is due to benzene. Benzene is due to vehicles. So air quality index and other things was prepared in India. So this is the color code given by the Central Pollution Control Board, and based on this color code, the air quality index is given. As per Hyderabad, so it is color is around moderate pollution. As of now, Hyderabad is having moderate pollution. A poor condition is not so far appeared. It will come in some occasionally, very rare, but where we see Delhi and other things, it is always very poor and severe, but we are in ranging with good, satisfactory and moderate pollution. Okay, so with this I think these are the some of the health impacts where whatever they indicate. Moderate pollution is Hyderabad means breathing discomfort to the people with lung diseases such as asthma and discomfort to the people is there. So with this I want to close it. Thank you very much for giving me an opportunity. Thank you.
Thank you, Ravindra Garu.
Thank you.
Now, I will introduce today's another speaker, S.K. Gupta Garu. He is a civil engineer from IIT Kanpur. He has been working in the field of environment for the last 38 years. He pioneered the development of indigenous technology and instrumentation for monitoring air pollution and air quality in India way back in 1981-82. He set up Envirotech Instruments, a company to produce indigenous instruments, which produced India's first stack monitoring system and later respirable dust 2.5 and PM1 samplers for monitoring ambient air. Also set up nearly 100 real-time monitoring stations across India and made them work. Currently, he is working with IIT Delhi and IIT Madras to develop indigenous sensors in India for monitoring PM2.5, CO and NO2, and with IIT Jodhpur to produce an indigenous odor monitoring devices. He is having rich experience in EIA and EMP studies. He has also been instrumental in initiating hands-on training programs. He is associated with Indian Association for Air Pollution Control since 1980 and currently Secretary of Delhi chapter. This chapter is now a body of 600 scientific personnel working in this field. His initiatives and efforts have helped the country to develop indigenous capabilities for monitoring our air environment. He is really an asset for the country. So I request S.K. Gupta Garu to deliver his speech. Unmute this one. Please unmute yourself. Gupta ji.
साहब आप अनम्यूट कर दीजिए साहब. महेश अनम्यूट कर दीजिए सर. अपने आप अनम्यूट कर सकते हैं गुप्ता साहब. हाँ ओके.
Okay.
Okay, am I unmuted now?
Yes, audible.
Okay, thank you, sir. Thank you. Good morning to everybody. And first of all, I would like to convey my sincere thanks to Mr. Narayan Rao and my friend Ramanjalu for inviting me to this August gathering of Institution of Engineers. And I also wish to convey my thanks to the Mr. Raman Naik and Mr. T. Anjaya for giving me this opportunity to present my views. I shall share my experiences of last 4 decades in this field, and I'll try to do the best of my ability. Can I share my screen with somebody? Will somebody allow me to?
Mahesh?
Can I share my screen?
महेश कोई सार
Mahesh, can you help me? I'm trying to share my screen, but I'm not able to get this. Post disabled participating screen sharing.
महेश को हेल्प चाहिए सर को स्क्रीन शेयरिंग.
I'm getting a message that host disabled participant sharing screen.
మహేష్ వాళ్ళు చేస్తుందా స్క్రీన్ షేరింగ్?
Sorry, sir, some technical problem. Can you hear me, sir?
Yes,
sir,
I
we
am
already
able
given.
to hear you.
Sir,
आप फिर से शेयरिंग पे आ जाओ.
already given share screen, sir. Please click on share screen.
I am trying, sir. I am trying, but it says that
पार्टिसिपेंट्स का शेयरिंग अपने आप
Here you have share screen option, sir. Your desktop.
I am trying to share my screen, but I am getting a message that host has disabled participant to share the screen. So,
Okay.
एक बार ही ना लॉग आउट करके दोबारा लॉग इन कर दो तो हो जाएगा. कहना कि मैं दोबारा लॉग इन करता हूँ लॉग आउट.
I'll try to log out and log in once again. Give me some time.
लीव करिए.
ये आराम से कीजिए सर. नो प्रॉब्लम.
Sir, don't worry, sir. No, don't log.
Okay.
सर मिस्टर महेश
You will help me share. Okay. You have my presentation with you, Mahesh?
No, I don't have, sir.
I sent you on the email.
Once again, share your screen, sir.
Okay, just a minute.
Okay.
चलते चलते बंद हो गई.
Yeah, अब
आगे.
इसमें एक ये है ना मेरा presentation.
हाँ ये
इस पे कर दूं क्लिक.
हाँ और यहाँ पे शेयर.
Okay.
सर. ओके सर बढ़िया.
Yes, my screen is shared. Okay. Thank you, Mahesh ji. Thank you.
Thank you, sir.
Please continue, sir.
Yeah. So, friends, my talk will cover 5-6 issues. First, I would like to briefly introduce the importance of air quality, then concern for air quality in India, and then issues and challenges which we faced in 1980s when we had this concern, and appropriate technologies for air quality monitoring, and efforts made by my company Envirotech to address these challenges, and some issues and challenges we are still confronting our country, and some suggestions from my side. So if time does not permit, then I will cut down a few things, but these are my total overall presentation. So friends, I would like to first highlight that air quality is very important for everybody, because everybody is immersed, all life forms are immersed in this. And the first 200 meters of this air pollution, air quality atmosphere is very important for us, because this is the area which directly is affecting. So air pollution is affecting human health, vegetation, crops, plants, groundwater, mercury. We have noticed in Singrauli areas, materials like we all know the history about Taj Mahal, then livestock. And most important thing is that these effects of air pollution are localized and they are governed by local meteorology. This is a very important aspect which we have to understand, that this air pollution effects are absolutely localized. They are not global, but the impacts are local, and they are governed by the local meteorology of that area. I'll share one screen with you in which we had carried out some studies long back in 85s, during the 85-90s, with the help of medical college at Kanpur. What we try to do is we try to find out what is the impact of air pollution on human health. And in air pollution also we took dust as the main parameter, because we felt that dust is a very, very important parameter in this air quality. And this is directly impacting the health of our human beings. And what we did is we tried to find out the prevalence of respiratory disease due to this air quality variations. At 4 locations we did this study, and at Bokajan we did, at Kanpur we did, then a cement plant at Bokajan, a refinery at Haldia, and refinery at Barauni. And what we noticed is that if SPM level are up to 300 microgram per meter cube, then the incidence of cases of respiratory diseases in 1,000 people were 23 at Kanpur, 32 at Bokajan, 36 at Haldia, and 26 at Barauni. And when this level increased from 400 to 500, the incidences doubled. They became 43, 66, 88, 49. And when this pollution level or dust level increased to 600 to 700 levels, the incidences of respiratory diseases increased from 98, 166, 106, almost 4 times. So this is a small study which is a very eye-opener. This was done long time back, about 30, 35 years ago. But I think the impacts can be understood by this very well. Similarly, we did a study on eye and skin symptoms. Same thing we did at the 4 places. And we found that if levels were up to 300 microgram per meter cube, the incidences were 45, 38, 5, and 14. And when the quantities increased from 400 to 500, incidences became 103, 82, 19, 16. And when the dust levels increased to 600 to 700, these incidences became almost 10 times, 412, 125, 58, 60. So this is just to indicate that how air quality is impacting human beings. This everybody has understood that for humans, air is a very, very vital component of the environment. And therefore, in constitutions of all countries, right to clean air and water has been ensured for all citizens. In our own constitution of India also, there is, it is there. And because of this, I think act, because this provision in the constitution, an act was enacted in Air Pollution Act was enacted in 1981 to maintain the wholesomeness of air quality in India. And as I mentioned, that's what are the sources of air pollution, which everybody knows, but the main major sources of air pollution or which affect the air quality are industrial activities, mining activities, transportation activities, urbanization, and local meteorology. So we have to understand that these are the real causes of deterioration in the air quality. And therefore, management requires that we should manage these activities in a controlled manner so that minimum emissions are released into the atmosphere and they remain within the prescribed limits or for our safe limits. Thus, there is a very important requirement that for air quality management, intensive and extensive monitorings are essential. You cannot get away with it. What do we have to monitor? Or from where we have to monitor? This is a small slide which says that you have to monitor from ambient air, outdoor. You have to monitor from inside the houses or inside the offices, inside the work areas. You have to monitor fugitive emissions. You have to monitor from stationary sources like industrial chimneys. You have to monitor from mobile sources, which are transportations. So these are the sources from where regular monitoring is essential. Now, I am coming to the concern in India when this concern arose. I think the main concern, you all know that in 1970s and 80s, there was a refinery which was being set up at Mathura. And opposition to that refinery arose because there were apprehensions that the emissions from this refinery will affect the Taj Mahal. And there were cases filed in the Supreme Court during that time that we have to protect the Taj Mahal. Similarly, there were incidences of acid rain in Bombay, in Chembur area, where Rashtriya Chemical and Fertilizer Plant was located. And there were some small incidences of acid rain in that during that time. So people were concerned that yes, air quality is becoming an important issue, and we must take steps to maintain the wholesomeness or protect the air quality or improve the air quality. So therefore, these two incidences led to the promulgation of Air Act in 1981. And after that, several steps and actions have been initiated. Like Ravinderji mentioned, or recently we have a National Clean Air Program to improve the quality of air and protect its quality. But unfortunately, we have seen a constant deterioration of air quality in last 4 decades. So I will now slightly briefly highlight what were the issues and challenges in 1980s. The issue was that all industries were required to monitor emissions to keep them under limits. But the real problem was industries were not ready to initiate monitoring because there were no instruments available in the country. There was no manpower, skilled manpower available in the country. And more importantly, there was a very strong belief in the industry that we do not have any air pollution problem. So this was a mindset which was there at that time, that we do not have a problem. Especially larger industries also did not agree, and the smaller and medium scale industries in fact said that even if we have a small problem, how much are we going to contribute? We are very small units. We are going to emit very, very low emissions. So this mindset was very crucial at that time, that yes, there was no recognition of this fact that there is a air pollution problem. Then PCB staffs who were employed in pollution control boards, they were slightly not aware of the various problems in the industries, and therefore there were weak inspections by the PCB staffs, and therefore the effective emission control could not take place in the industries. And by the community, it was a very ineffective vigilance by the community. The people living around the industry, they were not able to exert pressure on the industry to control their emissions because they were getting jobs and they were getting opportunities to work in the industries. So there was very ineffective vigilance and action by the community. And then we developed our air quality monitoring programs, but there were some flaws in those planning because we lacked understanding, and there were flaws in planning and designing of air quality monitoring network in the country. And there was very low emphasis on critical pollutants like dust, SO2, NOx, CO, and ozone. These were CO and ozone were not even considered as pollutant at that time, although their smaller, small time duration exposure is also very lethal to the human health. And thirdly, there was no sort of appreciation or recognition that local meteorology is playing a very important role in the air quality management. So these were few issues which constrained us in developing an effective action plan. Then after this act, the technology development efforts started in the real sense in the country. And first act enacted by the Indian Parliament said that all industrial units must check their emissions coming out of their plants and keep them under prescribed limits. Industries were given consent to operate if their emissions were under limit. If they were not under limit, they were refused consent to operate. So this was a very important requirement. Now, as I mentioned, there were no instruments available in the country. So there was a need to have instruments in the country. So country looked around and tried to find out what are the instruments available, how other countries are doing, what do we do in our country. So we all Indian government and industries all noticed that in industrialized countries, especially in USA, Japan, and West Germany, they've all shifted to automated monitoring of industrial emissions, and these were based on some physico-chemical or electrochemical properties of the pollutants. And such instruments all require very specific sensors for each pollutant. The calibration procedures needed calibration gases of exactly specified and known compositions, and they needed dust-free and air-conditioned environment for their main modules, keeping their main modules. So these were the difficulties in importing these automated emission monitoring devices. And it was also realized that such systems would be almost unaffordable from the capital cost point of view, particularly for smaller and medium scale industries. And it will be more difficult to maintain them because of the non-availability of spares in the local market and calibration gases in the local market, and from where to find this competent and trained manpower to operate these automated continuous monitoring systems. On the other hand, it was also noticed that US EPA, United States Environmental Protection Agency, they have developed simple concept for monitoring source emissions and also ambient air quality. So India looked at these small, simple concepts and observed that these concepts can be sort of copied or adopted, and instruments can be developed based on these simple concepts. So these concepts might have become obsolete in industrialized countries, but they were quite suitable for developing countries like India. And therefore, the most viable option for India appeared to develop our own indigenous simple instruments based on these US EPA concepts and at affordable cost. So this was a very great possibility which the country saw, that why should we import costly, unaffordable emission monitoring systems? Let us develop our own indigenous instruments. So at that time, my company Envirotech, which was there, which came into existence at that time, and they started this challenge, took up this challenge, and produced India's first emission monitoring system in the country, which was very low cost, simple in design, easy to maintain and operate in the field, and it became suddenly important, very popular in the entire country. In the ambient air, US EPA had also developed simple concepts, and they had pointed out that monitoring of dust in the ambient air is dependent upon the particulate deposition in the human respiratory tract. Initially they were monitoring suspended, there are three kinds of particle sizes which are very important. One is a suspended particulate matter, that whatever emissions comes out in the atmosphere, they remain suspended in the air for a long time. So that is why they are called suspended particulate matter. Then out of the suspended particulate matter, some particles are inhalable. They come into our respiratory tract. So we call them inhalable particle or respiratory particles or respirable dust, or nowadays it is usually called PM10. Then later on, it was also realized that some particles penetrate deep into our system, lungs, and they are finer particles, which are usually nowadays called fine particles or PM2.5 particles. For monitoring gaseous pollutants, USA again had simple concepts. They said that why can't we measure all the gaseous pollutant by wet chemical methods? Any chemically reactive component is detectable in this, and normal laboratory performances are sufficient, and these are accepted as basic reference methods. Their internal calibration is possible, and they are simple instruments, and they're low cost. So country adopted these wet chemical methods at that time, and they're still popular, and they're still affordable in our industries and regulatory frameworks. Around the 20th century, 21st century, I would say, continuous real-time monitoring became slightly important, because everybody wanted to know what is the diurnal variation of these emissions from an industry, or in the air quality, what is happening at what time, and for how much time those pollutants are present in higher concentrations. So this means we needed real-time monitoring devices which would give hour-to-hour values or minute-to-minute values, or variations during the daytime. The ultimate objective was that if we know this information, then we can develop air quality management plans according to that. So we took up this challenge that, okay, we will also try to set up this station and learn about it. And we set up our first station at Hyderabad. But before that station, we took up that work. We tried to find out that about 100 stations, odd stations, were already set up in the country before 2000, and they were all inoperative. So we tried to find out the reasons. So I will tell you what were those reasons. But this requirement became in the country very important, that we must have this continuous real-time station monitoring devices. And they work on this principle that they take sort of this dust, air from the environment, and it goes to through a probe pipe, and they go to the analyzer systems, and then from analyzer the data goes to a data logger, and from data logger it can go to the cloud server or anywhere, so you can get the data instantaneously also, and also in the analog systems or in the digital and in the display systems. Nowadays we are talking of low cost sensors. We're saying that monitoring should become cheaper, more affordable. So Government of India initiated a program in 2015-16 and said that all IITs who are working in the field of environment can submit a proposal to the Government of India for the frontal technologies. So IIT Delhi and IIT Madras submitted a proposal to the Government of India that we will develop low-cost sensors for monitoring of this pollutants in the atmosphere. They took up 3 parameters: PM2.5, NOx, and CO. And they have developed a small device which is based on holographic technique, and it is under trial, and it is expected that this trials will be over by this year end, and this indigenous low-cost device. This is a unique development in the country, that for the first time this development is taking place within the country, that we are developing these sensors within the country. Otherwise, at the moment, all sensors are getting imported either from Western countries or largely from China, about which quality is always doubtful. So this is a good development which is taking place in the country. And based on these three experiences of our manual devices developed on the basis of US EPA concepts, then continuous real-time monitoring systems, and then low-cost sensors, which we are developing with IIT Delhi and IIT Madras, we found that manual samplers have several advantages and very suitable for a country like India. And they are definitely more suitable for our environmental conditions and our cultural conditions. And there are several advantages in this, that this sampling is based on primary method. They are not measuring the secondary property, you are measuring the primary property. So they are called reference systems. So whatever information you get through manual samplers, this is considered to be more reliable, more authentic, and more trustworthy. And then you get a physical sample in a manual monitoring. So when you get a physical sample of dust or gases, then you can do the chemical composition of analysis of it to find out what exactly is available. Or suppose you have a dust sample, then you can do the analysis of that dust to find out what exact constituents are there in this dust. These are simple to operate, they are portable, they are low maintenance, they are easy to handle in any adverse conditions. No competent manpower is required to operate. So this is a very important part, because in our country, the development of manpower has been still a challenge. And as compared to SAMs, or no requirement to calibrate them in a very elaborate manner, and they are indigenous and low cost. So what we did is that when we came to know that these are the requirements in the country and what country would need, so we tried to last 4 decades. First, we tried to get an insight of the problems. What is the problem? What are the environmental conditions in which we have to produce these instruments or other things? So we found that in the entire country, power supply, irregularity in power supply is a problem. Variations are, voltages are there, frequency variations are there, and non-availability of earthings are there at monitoring locations, especially in rural and forested areas. So in such a situation, you have to have only those kind of instruments which can fairly operate in these conditions. You cannot change these conditions. So you have to tailor-make your instrumentation development according to that. Then there are variations in our weather conditions, different parts of the country, from extreme hot and humid to dry weather to extremely rainy and cold conditions. So the instruments must be operable in all these environmental conditions. Then we have rough terrains in various parts of the country, so that there is a great difficulty in transportation of instruments. So we thought that unless we know what are the problems, the development of instruments will be not proper. So we understood these problems, and we then developed instruments in these environmental conditions. The second aspect was that manpower, which I mentioned, that there was no manpower. And manpower is still a challenge, because there are no formal trainings available in any of the educational institutes which are teaching environmental science as a subject. These facilities are also not available at any of the ITIs. So where do people get trained? This is a very big challenge and issue before the country. So in our opinion, we felt that industrial locations offer the best opportunity to get proper hands-on exposure and learning and training. But unfortunately, these opportunities at these industrial locations are now shrinking, because industries gradually stopped monitoring themselves, and owners of the industrial units are not interested in building up this manpower. They are only interested in obtaining consents to operate or their annual renewals so that their operation continues uninterruptedly. So in such a situation, how do we train people? Where do you train people? So these opportunities we'll have to recreate once again. And for recreation, the only solution is that industries must start doing monitoring themselves. They should build monitoring infrastructures. They should hire people. They should ask them to monitor so that people start getting trained and developed in this monitoring. I will just quickly go through the instrumentation which we developed. This is the first stack monitoring. These are various models of the stack monitoring systems which we developed in the country in 1980s and then later on. And this is a high volume sampler which measured the total suspended dust. I mentioned SPM. When the emissions go into the atmosphere, they remain suspended in the air. So there was a need to monitor SPM from the atmosphere. Later on, when it was realized that we need to measure respirable dust, so we developed this respirable dust sampler with a know-how from Niri Nagpur. Why we went to Niri Nagpur? Because we wanted that this equipment should still remain portable, still remain compact, and it should have a separation device which is almost certified and verified, so that nobody doubts that whatever you are measuring out of this respirable dust is correct. So they developed a small cyclonic device, and which we inserted into our high volume sampler and produced this small, almost same size device. And this was such a unique development that it offered the mobility to the instrument. And because of this mobility, the measurement of respirable dust became very easy and convenient throughout the country. Then later on, when the need for fine dust particulate measurement arose in the country, because fine particulates get trapped into they reach our lower lungs and get trapped there. So we developed a PM2.5 sampler, fine dust particulate sampler, based on US EPA standard design. What US EPA did is that in 2000, they developed a design for a sampler and put it on the public domain. And they said that all countries can adopt this design and produce samplers. So in India, we took this design and produced this sampler based on that design. And then later on got it verified from Niri Nagpur that yes, is it as per US EPA? Is it suitable for PM2.5 monitoring? Which they did. These are those gaseous sampling attachments which I mentioned, that gases can be measured by simple wet chemistry methods. So these are impingers. In impingers, you have put a reagent and absorb a particular gas from the atmosphere. And by doing the analysis of that, you can know the measurement of gaseous pollutants. Now, PM1 is also becoming important, that fine dust, then ultra fine dust. So we developed this ultra fine particulate sampler with know-how from IIT Kanpur, and almost about 100 pieces of this sampler are in use with various educational and research institutions, and they are collecting data. And Government of India, CPCB, is also working to revise the National Ambient Air Quality Standards by next year. So by that time, a lot of data will get collected on the PM1, and maybe this parameter will also get included in the National Ambient Air Quality Standards. Then in 2009, CPCB had introduced 4 heavy metals into our National Ambient Air Quality Standards: lead, arsenic, nickel, and benzopyrene. But and they prescribed that their annual averages should be measured, and concentration levels in the ambient air should be compared based on that annual average standards. Now, suppose you have to collect an annual average of a particular pollutant. This means you have to do the sampling for an entire 1 year and get a sample, representative sample for an annual average. So if you use a high volume sampler or a RDS, respirable dust sampler, This means which operates for about 24 hours. This means you have to collect almost 300 samples. So what we did is that in this sampler, we introduced a device which can operate or allow this sampler to run for 30 days or 40 days at a time. So this means only 12 samples are required to be sampled, and annual average can be easily worked out. So this is a good device which now people are trying to use it and make it suitable for the country. Now, Ravinder Sir mentioned about a lot of things about this uh, uh, incineration
Gupta ji,
requirement, incinerator requirement.
Gupta
Yes,
ji,
sir. Yes, sir.
as soon as possible.
Okay, okay, sir. Just give me
Okay.
5 more minutes. I'll cut it. So we developed a low-cost sensor-based system for measuring odors, so that the community can be alerted if there are odors in their area, and it can be sort of. I'll just take some 1 or 2 minutes on this local metrology. That we felt the need for this measurement of local metrology and mixing heights, because in an area, if you know the mixing height is almost like a virtual atmospheric height above which pollutants, suppose there are emissions above it, they cannot travel down to the ground level. So if we know the mixing heights in an area, then it will be very easy to develop air quality management plans. Unfortunately, this information is not getting collected in the country, and unless and until industries, larger industries, set up these devices, that they must know what is the local meteorology. Local meteorology means wind speed and wind direction at least. So wind direction is very important, because they would know in which direction their pollutants are going. And wind speed is important, how far they will travel. And this SODAR kind of device will help them to know how much is the mixing height in that area, so that their chimney heights can be specified above that mixing height, so that no emissions will come down on the ground level and affect the communities. Okay. So I will skip these slides. Just a minute. Ravinder Sir was mentioning about the monitoring vans. So we created these monitoring vans to facilitate monitoring in a mobile manner. And this is the station at Hyderabad, which we installed in 2005, continuous ambient air quality monitoring station. And we made it work. As I mentioned that I had set up about 100 monitoring stations in the country, and I saw to it that they all work. And this confidence of our Indian expertise is developed, that yes, we all can operate this. Otherwise, this impression was there in the country that no, Indians cannot operate this continuous ambient air quality station. And when we ran this station for almost 3 years, it ran without a single day breakdown. Now I'll just talk about some issues and challenges which are still confronting our country. In the environment management, we are still paying more attention to publicity rather than action. So all attention on environment is still for publicity. And we are still having this elitist approach of copying the West with no consideration of our own culture and even environmental conditions. Unless we accept this, that our environment is unique and we have to develop things according to our own requirements, I don't think we would be successful in this. And large scale adoption of Western technologies are still being adopted without making necessary modifications or make them work appropriate for our environment. And Western measurement techniques and imported measuring instruments are still being preferred. And in monitoring methods also, we are still relying on setting up these continuous ambient air quality stations, which are very costly and not serving the purpose. So these are some 4 suggestions which we thought based on our 40 years of experience, that if we have to improve air quality or manage the air quality better, then we have to pressurize and empower all major and medium scale industry units for self-monitoring of their emissions. Unless they start this and stop depending upon the consultants, I don't think air quality management will ever take place in the country. And we have to national ambient air quality structure we have to develop infrastructures and initiate regular air quality monitoring in all urban and industrial centers. And measurement of local meteorology, including mixing heights, has to be made mandatory at all major urban and industrial locations. And based on that information, we have to develop air pollution assimilation or carrying capacity studies, which will tell us how much load this environment can take in a particular area. If we do not know that, how we will develop a air quality management plan, or how we will develop our development of urban plans or air quality management strategies. So, friends, I think stop here. Otherwise, there are two, three more slides. I will only say that Envirotech, which is my company, would continue its efforts to seek knowledge and support research to develop newer techniques and instruments to monitor the environment, especially the air quality. We seek your support and guidance in this endeavor. And thank you all for giving me a patient hearing to my thoughts on this issue. Thank you, sir. Thank you.
Thank you, Gupta ji. Really, you have enlightened us a lot, and there are further developments
Yes.
that are to be studied according to you. And now I call upon I.N. Karmakar, OISM Chief of Staff, Ahmedabad, and he will deliver his lecture now.
Thank you, Dr. Rao. I'll just share my screen.
So, IND,
yes.
If you can finish within 15 minutes, it will be better.
Okay.
Possibly.
I think if the other screen is not shared, I hope. Yeah. Okay.
आपका स्क्रीन आ गया कर्म सोच.
Okay. Thank you.
बहुत बढ़िया है.
Thank you. Okay, thank you, Dr. Rao, for giving me this opportunity. I'll try to squeeze in as much as possible at this time. Without any delay, so I'm going to talk about what we have been doing in this field for a few years. At OISM, we have been building this smart, cost-effective, and highly scalable solution towards offering air quality monitoring and, of course, the advanced data analytics. So, which is in lieu helping the communities, industries, and the government in the future for correct decision making. So, in the course of this presentation, I'm going to talk about the challenges and the issues and what's the way forward as we move with the affordable technologies like sensor-based air quality monitoring. So we actually started our journey from 2015, and we have been getting ahead with global as well as the Indian smart cities. They have been some acceptance towards deploying the sensor-based air quality monitors. And today, just to give you a scenario of how people have started accepting this technology, we have around 500 installations across 40 countries. So from there, we all started with thinking that we all know about these facts where pollution is the fifth largest killer and responsible for around 4.2 million deaths. So what we understood is that what is stopping us to getting deeper into the problem, as my previous speakers have been highlighting the points very nicely and over the period of time, how things have evolved. So we understood that data is the key to understand any complex problem. And we found out that the current solutions may be a little expensive or complicated or maybe labor intensive, which is kind of restricting that part. So we developed this simple, cost-effective, and the highly scalable solution, which can measure across 30 parameters like dust, emission gases, odorful gases, noise, radiation, and weather conditions. And in addition to that, we also gave a data platform for actionable alerts or insightful reports and predictive analytics, which will give a holistic view in case of any hotspot identification, as Dr. Rao was mentioning earlier, or any complex problem that needed hyperlocal data monitoring. So the evolution, as we just saw in the previous cases, so there were certain restrictions when it came to deploying of manpower, or if the data was not available on a real-time basis. So all those limitations were now in this third generation system, which are the sensor-based monitoring, which are smarter, leaner, and cost-effective. Even sometimes to check it when we talk about affordable technologies, they are sometimes 10 times cost effective, compact and scalable. So this is how generations have evolved with air quality monitoring technologies. And we are looking towards a future with sensor-based monitoring as an affordable solution. To talk about the solution, currently the systems, as I was mentioning, there are 30 parameters. So dust particulates like PM1, 2.5, 10, and 100, they have already been incorporated. Gases like SOx, NOx, carbon monoxide, ozone, and carbon dioxide. Categorizing as odorants, we also provide hydrogen sulfide, ammonia, chlorine, formaldehyde, VOCs, and captains, and of course, meteorological parameters with wind speed, wind direction, rainfall, and all. So when we talk about the working principle, most of these sensors, they work on electrochemical sensing. Few of the sensors work on NDIR, that is non-dispersive infrared, and other odorants, they work on PID, that is photoionization detector. So we have, over the years, we have identified the best technology that is suited for a specific parameter, and we have then deployed it with our system. One important part is to be communication agnostic. That is, any kind of communications when it comes to wireless or wired have been incorporated, because we never know where the systems are getting deployed at what remote corner. So the systems can work on GSM, Ethernet, Wi-Fi, or even Modbus or LoRa, which are some of the industrial protocols. So I'm going to just show you a short video after this, which will give you an idea of what the technology is and how you will make a sense of what I have been saying. So the next slide will be a short video of this technology.
Here is a state-of-the-art environmental monitoring solution by Oizome. It's a compact, ultra-low-powered system which can work fully on solar power. It works continuously and sends various environmental data related to air pollution, odor, weather, noise, and radiation. Its patent-pending e-breathing technology makes it highly accurate compared to industry standards. It can do complete gas analysis by monitoring pollutants like carbon monoxide, nitrogen oxides, sulfides, ozone, ammonia, hydrocarbons, and many more. It counts every single particle present in the air sample using a highly accurate laser beam. It is capable of monitoring particulates of various sizes, ranging from 1 micron to 100 microns. A downward-facing Class 1 noise sensor is ideally positioned to capture environmental noise up to 140 decibels from various sources. As you can observe, the top-mounted pyranometer does solar radiation analysis by diffracting the light rays into UV, IR, and visible light spectrums. Most of the pollutants are invisible, but through systematic data collection, they can be made visible. Oizome is committed to decipher hyperlocal environmental data and redefine natural resources, which are highly essential for our existence on Earth.
So these products, the units, rather the sensor-based systems, they have certain features which have been useful, which have been we have got from as a feedback from the users over the years. So they have real-time data transfer, they are weatherproof, there's IP protection, there's theft resistance, there's tamper or vandalism proof, which are kind of some requirements that we have faced over the years. And obviously there are 8 different modes of communication. And lastly, a very important factor is that there is a battery backup, which does not stop the monitoring in case of any power loss. So those are the features that we have been getting in over the years. The units, now when we talk about sensor-based systems, there are certain questions or queries regarding the accuracy of the data. So the units have been ensured by e-breathing technology. So that is like biomimicry of a human lung. So at every sampling, there is an inhale of 325 ml of air, and then there is an exhale. So every single reading, this phenomenon repeats and applies for particulate as well as the gas measurements. For particulate measurements, we have observed that humidity sometimes plays a big role. So there is a provision of a heated inlet, which nullifies any possibility of humidity, which again gives a better accuracy. Obviously, these systems have been patent granted and in EU and the US regions, and there are 12 trademarks for the system that we have got. Now, to speak about the solutions or the applications where we have been deploying this. So over the last 5 years, there have been 500 locations where there are different applications have been identified. So there are categorized in industrial as well as urban applications. So in urban, we have seen that smart cities, airports, and road safety, there are certain applications where they have requirement of such type of affordable technologies. And in this industrial, there have been dust separation, there's been solid waste management and wastewater treatment plant. So this is how the applications have been identified. I'll tell you one by one as I proceed. Some of these key projects that we have been doing, which have given us the confidence of promoting this technology and applying with the impact that we have created. So there was this data-driven healthcare actions for residents in Palava city, that is real estate developed by Lodha Group. Then there are smart cities like the Agra smart city, where we have developed. Then in Riyadh, that is in Saudi Arabia, we have the environmental penalties in case of any airplane emissions goes above. And obviously in Kanjurmarg, there is this landfill site which uses for efficient odor management. So with the flagship products that we have, like Weathercom or maybe Destroyed or Pollutron, we have been identifying these technologies where the systems have already been deployed and creating an impact. To give you an assessment of how we have been going, as I was mentioning, the urban and the industrial loop. So the action forces, we generate some KPIs for the key performance indicators for some government agencies, and then they can track it and measure the KPIs based on the air quality data, and so on. That loop is covered. Whereas in the industrial thing, it is more on the automation. So sometimes like there is a dust in a mining site and they want to suppress it using a mist cannon. So they can automate it based on the data from our device. So there's a relay based system, and you can, the technology is there to automate that kind of application. So these systems, in addition to a very good data analytics platform, give a comprehensive solution to the user, and they can then so if there are researchers, there are academicians, there are people from the industry who want to work on developing models. So all those possibilities can then be focused. I think Ravindran ji was mentioning about these possibilities, and this is where we have been already doing this. So in the past, to quickly give you a brief of the individual the units that is Pollutron, which is a capability of measuring all these parameters mentioned in the AQI. So PM10, 2.5, CO, NO2, SO2, all these possibilities are there. And the applications have been brilliant as far as where people have started using this in smart city planning or campus monitoring to hotspot identification, as I was mentioning, the airports. So these applications have been brilliant as far as using these technology, affordable technology for creating an impact. Same way, the flagship goes with odor monitoring solutions, where we can measure ammonia or hydrogen sulfide, the mercaptans, formaldehyde, and we have been deploying it in landfill sites or wastewater treatment plant to give data-driven process improvements. So it's not only just monitoring and creating maybe an overall picture from an annual data. It's also on a real-time basis if they want to, if the technologies can help to improve their processes. So when those cases have also been identified where people have been using the systems. Of course, when we focus it on only dust particles, we all know how critical that issue is. We have been discussing it in the previous two presentations. So particulate matter 2.5 and 10. So as Gupta ji already gave a very good picture about what is respirable, what is fine. So I'm not going to get into that, but once we applied on, recently there was a law passed in the Delhi and the NCR region that they wanted to measure the PM in the construction zone. So that is how grief this problem is, and everyone needs a solution to monitor that and then take actions based on that. So mist cannons, as I was mentioning, the dust separation, it is already there. The applications have been inside any huge construction site or mining site where the mist cannons have been automated based on the data. So how it works is we set threshold values. If let's say it's 100 micrograms per cubic meter, and if the value exceeds that, automatically the mist cannons can then work around. If you add the wind direction as another parameter, it can also create a rotation basis. So all those possibilities can now be done with such real-time data. This is another unit that we have, that is WeatherCom. So as I was mentioning, meteorological parameters can then be added to this for a holistic view of, but we don't want to get into that. The part that I wanted to cover, very important, is the calibration part, which I'm going to take some time and explain how we ensure that all our products get highest level of accuracy that is possible. So each and every unit undergoes multi-stage quality checks. And this all setup, we have done it here in Ahmedabad, which I'll just show you a picture in the next slide. So firstly, there is a factory calibration where the right mixture of gases is passed through each sensor to validate the sensitivity. And then comes the lab calibration, where there's a multi-point span calibration. So we use a dilution system with SI traceable gases. Example, like if it's a 550 ppm of CO, and it can be diluted to 50 ppb or 500 ppb and 5 ppm, and that can be done, and we ensure that we account for any cross sensitivity or any such other interferences. And lastly is a collocation calibration. So when we have an access to any reference grade system, we deploy it with the system for 1,000 plus data points, and we come up with a correlation for the accuracy part. So this part we have been doing with the US EPA and in Europe and in other parts of the globe, where we have identified certain reference systems and we have deployed it. Another such project was with the MPCB and IIT Kanpur that we recently participated in, where they deployed in 5 different. So we deployed in 5 different stations across Maharashtra, in Mumbai, sorry, and there was a correlation developed over a period of 9 months. So before going to that, this is our lab. It's an NABL accredited laboratory we have identified, which is at Atira, that is in Ahmedabad, and we all our units get certified here for any kind of calibration done. This is a typical image of how we do the collocation part, which I was just mentioning. So the units are, this is as per the US EPA guidelines. So we have to set it like not more than 3 meters within the inlet of the reference system. And there are certain ranges with the frequency of time. So 1,000 data points is one thing. And then we develop a chart with R-square values to give an indication of how accurate the systems are. So we did these kind of studies. So I'll just highlight one. I have a couple of more, but I'll just, because of time, I'll just highlight one. So this is with Horiba's station in Germany, and we found out that post calibration the R-square values were around 80% and an average, which varies from different parameters. So this is what we had found. Another such study was in Mumbai also with good results. So what we found out, at the end was there are various geographies across the globe. Some are extremely cold and dry, like Germany. Some are hot and humid, like Mumbai. Some are hot and dry, like the place I am in right now in Ahmedabad. So all those places we have tested and we have deployed the systems, and we are getting good results, which have really, we have gained some confidence in deploying these sensor-based systems, and how not only affordability is a factor, but also we are proceeding towards getting highest level of accuracy when it comes. In addition to this, there is also, only measuring the data is one part, but to make sense of the data is another. And we also developed an in-house software, so users don't have to download the data and make charts in Excel and all. So this is an in-house based software with advanced analytics, alerts. So you can get email alerts, you can get SMS alerts. So that is how the entire solution becomes very useful for whoever is using. So monitoring is one part, but making sense of the data is another. And we have tried to compile everything and provide a holistic solution. So this part, I'm not going to go into deep. This was just an addition to what could be the another addition. There are certain ways how the data is shown, which is where it creates impacts, like outdoor LEDs, as you see the advisory messages. So that is where people can get a sense. So this program in itself is for awareness amongst the citizens. So that is where this kind of data visualization helps in getting more sense of the data. So I think I'm going to skip this part because Dr. Rao has restricted my time for this. So these are some applications I'm going to quickly run through. One of them, that is smart city. So this is where we have been creating the impact so far with Varanasi, Agra, Surat, and where they deployed multiple devices for hyperlocal data monitoring. I'm going to just show some impacts created for Gandhinagar and Kakinada. So in Gandhinagar, there are across 40 such units, and they are placed with VMDs. They are smart panic buttons, and in a pole, this unit is installed, and real-time data is sent to the command and control center, where the city administration then keeps a check on the air quality and take any corrective measures from time to time. Similarly, for Kakinada, they have installed around 12 of them. And at the end, they have reduced the cost for monitoring by 50% by deploying these units. So such level of acceptance towards affordable technologies have taken place. I'm now going to show a couple of use cases here and there just to give an idea of where these technologies are making impact. So this is one where I was mentioning about the Palava Smart Campus, where they're displaying air quality data as an amenity and showcasing how the differences between the outside world and inside the campus. Same way, I think there was a mention of universities and researchers taking part. So in Spain, the Granada University, they have already taken the initiative a couple of years ago. They've installed the device, and students are working on what kind of advanced research can be done using the data. Another such application was tunnel monitoring. So this is King Abdullah's tunnel at Mecca. So there we have installed, and during the extreme traffic, they are measuring the vehicular movement and automizing the ventilation across in the tunnel. So that is another application that we have been working on. So this is a classic case with the mist cannons, which I've been telling since the beginning of this, by automating that. So one such has been done in the JCB plant, where they have deployed it and automizing the dust monitoring by using the data. I'm going to skip this part. I've mentioned enough about it. Some wastewater treatment plant and sewage treatment plants where they're measuring the odor values, because it's sometimes it's in the middle of a community and there have been complaints raised, so they need to take immediate action. So email-based alerts and SMS-based alerts help them to take those corrective actions and take care of it in time. So those solutions have also been done. I'm going to talk about now whatever we have been speaking and the challenges that are there. So few things that we have been trying to do with our systems. We've been trying to work around with all these applications with 500 installations so far. We're now working towards preconditioning of the sample. So as I said, there are different geographies with temperature, humidity varying. So we want to make that uniform. Currently, this is done as part of the smart algorithms that has been developed, and we are doing it as a corrective measures. But we want to also work. We are already actually working towards making this possible. On the other part, there is a bottleneck towards the regulatory bodies. So we are doing certain studies or certain participating in whatever evaluation studies are there to make sure that our systems are recognized towards regulatory acceptance. So collocation studies, as I was mentioning with reference systems. So UACP has a huge setup where they are doing that. In India, IIT Kanpur has been initiated with Maharashtra Pollution Control Board. There is a Kerala board who also initiated that. We are taking part in as many possibilities. So as many academic researches that are happening. The last and the most important portion that we are also trying to as a way forward or is a cluster-based hybrid system. So what we are also trying to focus, which the other parts of the globe have initiated and they are using it, is we are defining a monitoring area in the city and identifying the existing network of the reference system and expanding their reach. So we can have one unit and we co-locate it with our sensor-based system and apply any necessary calibrations required in all parts of the deployment. So this way, this is a balance between the reference system as well as the sensor-based system, and that also provides easy calibration and the hyperlocal data. So all the possible requirements, all the limitations are overcome, and it's a holistic solution with the existing network and the new and the advanced and affordable technology. So with this, I think I have given an overview of how the affordable technologies as sensor-based systems have come into the picture. And we have been doing this since almost 5 years now with the beginning of the technology. And we have kind of been pioneers in applying this across the country. And we are now reaching towards more and more deployments and improving ours. So I hope this was useful and informative for our audience. Thank you so much for this opportunity, and thank you for hearing me out patiently. I'm open to questions. Thank you.
Thank you, Ayan Karmakar. Really, we have reduced the time for which you have to pardon us. Further, whenever we have the programs, we will invite you for workshops, you and Gupta ji, for full day on air pollution monitoring. Yes, Gupta ji suggested.
कर्माकर साहब बहुत बढ़िया बात किया.
Thank you.
हमारे गुप्ता साहब तो बहुत बढ़िया, हम everything explained systematically and properly, sir. All eminent engineers like our Shyam Prasad Reddy, Water Board Chairman, and Professor Ravindranath, Professor Emeritus, our Hara City, all are waiting, sir. We are very happy. And Professor Ramal Jayal, eminent professors are here. Our former chief engineers, everybody is here, sir. बहुत बढ़िया, गुप्ता साहब तो बहुत बढ़िया किया. धन्यवाद सर. I am requesting Professor Hana Secretary Ajay Garu, please propose vote of thanks. Sorry, Dr. Nandra Garu, please vote of thanks.
Oh, yeah. I once again thank SP Gupta ji, SK Gupta ji, and Karmakar and Ravinder ji for their excellent presentations. And I would like to thank Professor Raman Nayak and Anjay Garu for giving the opportunity for all of us to participate in this webinar. And we are also grateful to our Institute of Engineers for facilitating this webinar. See, we are sorry that we could not able to take up questions because we have another program just after 1 hour. Therefore, you have to pardon us for not taking up any questions at present. And afterwards, we will again conduct one more program on this air quality monitoring. So, namaskar for all, and we will stand up for
Jangamana. Mahesh, Jangamana.
Thanks, everybody. Thank you.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता.
Thank you. We will conclude this.
Mr. Ravindranath sir, happy, very happy. Welcome, sir. Thank you, sir. Welcome, sir. And Neil sir.
Thank you for all of